Hello, everyone. Welcome back to Aspect Insights, your favorite live stream and podcast about Bazel and its ecosystem. Or if it's not your favorite, let's be honest, it's the only one. My name's Alex. I'm your host. I'm the co-founder at Aspect Build. We make a monorepo developer productivity platform for large-scale polyglot repositories. Today's episode is a little different from those in the past. I do not have a guest. Instead, today's episode is a sponsored one. This means we will be talking about some commercial software. If that turns you off, I'm sorry. Please feel free to skip that part. The sponsor is, of course, my own company for this one, Aspect Build, and I'm going to be talking a little bit about the Aspect CLI to solve some of the problems. But the topic is bigger than that. The topic today is build file generation. So to motivate this, let's talk about what build files are in Bazel. And I'm going to share my screen for those watching the video version. Of course, I'll describe what I'm doing for those of you who are just listening on audio. So the issue with build files is that it's really a regression in the developer experience when a developer comes to try Bazel. Whatever build system they were using before, for all of its flaws or all of its assumptions about the way that you're supposed to write your code, it didn't make you configure it at the same level that Bazel does. Even if you're coming from something like Maven or Gradle, there's an XML file. It can be annoying. It might be groovy code. You have different ways of expressing your logic, but most developers can just go in there and type in whatever they want, right? And Bazel's configuration file is a whole new language called Starlark. It feels very unapproachable, especially if you're getting started, but also if you're in a really big repository and you have hundreds of engineers creating these things they don't really understand. And Bazel forces you to express that dependency graph in build files before you can even invoke the tool. So if you think of Bazel as being several phases, this part where you write the build files is not even a phase Bazel really thinks about. It's like phase 0. You're required to do this before you start running a Bazel build. So I call this a regression. I think what should happen, since build files really just contain facts, for the most part, 80% of the file is just containing facts that are a copy of the information that you already could see if you looked in the source files. So that's import statements and other things that can be just analyzed statically. So that really should be the job for a computer. So I'm going to show a little bit of a demo, and I'll talk through it as well, of course, to illustrate what I think the developer experience really ought to be. Okay, so let's start a new terminal. I'm going to make a clean directory just because I always like to make sure that I don't have anything cached. And I'm going to start off by running a command called aspect init. I'll mention this Aspect CLI in a few minutes. This is just a way to make a new Bazel repository. You could skip this if you've already got one you want to play in. And I'll call this insights just to promote the podcast a little bit more. Now I get some prompts when I run Aspect init. The first was the name of the project, of course. Now I can choose some languages. I'll choose JavaScript and TypeScript as well as Python. Right now it also has Go, Java, C++, and of course we're working on adding more. Hit enter. I'm prompted if I want to set up formatting and linting. Of course, I think linting is very important. We'll have a separate episode about that. We'll skip it for now. Version stamping, again, something that you could add to a larger repo. We're not going to be publishing releases. That's not important here. And then protocol buffers, let's not even get into that today. And so now we have a new folder. And also that folder has this README file in it. That's very important. You probably want to do something similar for your developers to understand how to use the tooling. And I'm sure somewhere, if you've started using build file generation, you already have a section in the README telling your developers what they're meant to do. Okay, so let's open this folder in VS Code. Again, this is a brand new Bazel project. No tricks up my sleeve. Oh, I pressed the wrong thing. Let's try that again. I have to trust the authors of this code, which is me. So yes, I trust them. So what I'll do is start a terminal, and I want to illustrate what the developer experience is like outside of Bazel. So just for example, since we have JavaScript in this project, let's go to the Node.js website and find the introduction. And of course, the first thing they have is some code you can copy paste. Everybody wants a getting started experience where they can jump right in and feel like they're doing something. And this says I should create a file called server.js. So I will create one, and I will paste the contents that they gave me, which is basically just require HTTP and then create a new HTTP server and then tell it to listen on a port. So kind of your hello world server code. Now, if on the same site, I might figure out how to run this thing. Of course, the simple way is not what we want today. It tells me how to install Node.js, which I can skip. So I'll just skip through a couple pages of this documentation on the Node.js website, get to the part where we're introducing package managers and finally how to run tasks, okay? So what it says is, if you're a JavaScript developer and you want to run this program, the best way to share that with other people on your team, the sort of build system, if you will, is to just add a scripts section to my package.json. So I'm going to do exactly that. Go back to our project we created, put the scripts thing at the bottom of package.json, as blind as can be. And now I don't need start-dev, and for this one, I named the file server.js. Okay, so I've just created a little package.json section that says how to run my program. Now, what would a JavaScript developer do when they're ready to actually see their hello world code run? They're going to type npm start. Simple, as short as can be. Okay, and now the server is running. I click on it, I see hello world in my browser. So that's incredibly satisfying getting started experience. What do we want to happen under Bazel? Well, I said we shouldn't have to write build files. That's probably the first thing you would imagine. This project already has some basic build files because it was created using Aspect in it, but it certainly doesn't know anything about the server code I just wrote. The answer is I'm going to type Bazel configure. I could also type Aspect configure. Aspect is the wrapper around the Bazel CLI. It says it visited some files, Python, JavaScript, not interesting. It updated one build file. So now what I can do is already I should be able to type Bazel run start. Start is the same name I gave in my package.json. There should be no build files to edit. And when I do that, I wait a little while for Bazel to boot up. This is the first time we're even talking to the Bazel server in this new project we created. And now the server is running. And if I click there, I see the same thing. So this is a very powerful example, I think, of what the developer experience with Bazel could be if we didn't have to worry about writing build files. If the tooling could understand what developers are already doing today, it should be able to do the right thing. Okay, so of course the problem is largely solved. And so let's talk about the solution that I would suggest everyone in the Bazel ecosystem should be using today, which is called Gazelle. Gazelle is based on a long lineage of tooling inside of Google. The giant Google monorepo is called Google 3, and the Go language was actually developed in concert with applications living in Google 3. So the two things were obviously meant to work well together. And so the Go team decided they did not want their developers to ever have to learn how to write build files, right? At Google, most people were forced to learn how to write them, and that was okay because we got a lot of good snacks and haircuts on site and whatever the other perks are. Obviously, I'm being silly. But this was a very important developer ergonomic that made Go more successful as they tried to compete for interest within Google at the beginning. So let's talk about how Gazelle works for a moment. It has basically 3 steps. The first 2 is a walk of the source tree. So in pre-order, so as we're descending down the tree, we just index the source code. So it needs to know how to parse and keep track of the syntax elements, especially import statements, right, that are relevant for how do I build this thing. That's the same thing an IDE does to give you jump to definition. The second thing is on the post order. So as we're popping back up the stack of that tree walk, then it's going to produce targets that belong in the build file. Based on its understanding at this point, after having done the tree walk of all of the subtree beneath that point, it now has enough knowledge to do that. And finally, after the walk is complete, then it needs to merge those results into the build files. And this is a critical step. It's a merge and not an overwrite, which means that it has this property of being non-destructive. So if you make hand edits in some syntax that it doesn't know about, it'll leave those alone. And if you touch syntax that it does know about, you can use this #keep comment, which is a load-bearing comment, but it works pretty well. And that'll preserve changes to that syntax that otherwise, whatever syntactic element that keep is on, which could be a whole rule. Then Gazelle, it was written for Go and obviously protocol buffers because every Googler spends a good deal of their time doing protocol buffers. But then other languages were actually added on later. And so what a lot of people don't know is that Gazelle is for more than Go and protocol buffers. It is for a bunch of languages. I do want to give a shout out to the developer behind this. Jay Conrad wrote Gazelle. It's a brilliant piece of software. You can see his commit history. When he worked at Google, he was paid to work on this, and then dropped off when he left Google. Of course, this happens. There are other folks who now have picked this up, including Fabian from BuildBuddy. I do want to make a plea, though, that since Jay's new employer does work in the Bazel ecosystem, it would be great to have a renewed ability for him to be paid for working on open source software like this. It's not fair for any open source maintainer to be expected to continue their passion if it's not connected to their job. Now, I mentioned that Jay added support for other languages. Here are a bunch of them. So Go, Haskell, Java, TypeScript, JavaScript, Kotlin, protocol buffers, Python, R, Rust, Starlark, and Swift currently appear on the README of the Bazel Gazelle repo. So that's pretty cool. To a large extent, if you're using these languages and you have any number of users in your repo, really, what you want to do is set up the Gazelle tool in your repo to make this a little bit more seamless for them so they don't have to write build files. Now, this has not entirely solved the problem, I think. In my experience, there's still a lot of people writing build files by hand, even for those languages I pointed out, and it's because of a few issues. So I'll run through them real quick. So first of all, the extension API is in Go because the Bazel Gazelle tool was written in Go. There's a proposal for allowing extensions to be written in some other language and use an RPC mechanism to communicate with the Gazelle host. I don't know if that will go anywhere. It would be nice. In the meantime, you have to write Go. That makes it a barrier to entry for developers who don't know Go, both to write new extensions, but also just to read them and be able to diagnose why the tool is behaving the way it is. So you can read the documentation on the Gazelle website, which explains how to extend Gazelle. You write a Go_library, you implement a new language interface, and so on. Now, of course, lots of people have written these extensions and then never upstreamed them. And unfortunately, that's just part of working in an ecosystem with a lot of corporate users, is that it's difficult to be able to sign a contributor license agreement. It's also very difficult to create software that works for you and everybody else and then publish it to the internet, because either, number one, they'll expect that when they find something weird that they wanted to do, that you're supposed to be on the hook to do that for them, or number two, they will feel like your company dropped this code here and is not supporting it. Anyhow, you can write one of these extensions. You can also ask your friends in the Bazel ecosystem, see if they know of companies who have written one that's just like what you need. Now, the solution to this is we can use a different language to write these extensions. And I think Starlark is the obvious choice. Why Starlark? Well, it is Bazel's configuration language. It's the one language anybody using Bazel has to know. You might have 0 Go in your repo, so Go doesn't make sense. You might have 0 Java or 0 Bash. There's really no language that is sort of common to all Bazel developers other than Starlark. So that's cool. It also means, however, that logic can be shared between rule implementations or macros and a corresponding generator for build files. And in fact, you could imagine some abstraction, let's call it my_abstraction. This is a macro that sort of stamps out a bunch of stuff in your build file. You can imagine that sort of like dynamic build file generation that happens when Bazel runs the loading phase and expands macros. It's almost an equivalent thing to do it statically instead, which would be a build file generator that wants to create those targets and actually write them to the build file. If you have Starlark on both sides, it's very easy to port logic back and forth, switch from a macro to a Gazelle extension and then back. It's also a lot easier to customize logic for your repo. So you don't need as many directives and comments, or you don't have to go upstream and find the implementation of the Gazelle extension that you're using. You can just make edits directly in your repo. So that's great. That helps to solve that second problem, which means now in order to do code sharing, we just use the load statement from Starlark, and we're up and running. Okay, the third thing is that users have to build Gazelle from source because there's no binary distribution. In particular, of course, because it has plugins that are written as Go libraries, even if it had a binary distribution, that wouldn't include the ones that you've chosen. So really the model is you have a Gazelle_binary rule, probably in your root build file. You pick which languages you want to have generation for, and then users of your repo, so developers, the first time they come in and type, let's get started, let's run Gazelle, it will compile it from source. Now, that's okay, but once CGO gets involved, it gets a lot harder. So there's an issue on rules Python where now that they're using tree sitter, and we'll talk about tree sitter in a minute, but that's a C++ library. That means the CGO has to work and it has to be able to compile C++ code. Now you fall into the usual Bazel trap where hermetic C++ is kind of big and hard to set up. And by default, it's non-hermetic, and so Gazelle may just not build on some people's machines, right? And there's an issue here on the rules Python repo number 1913, where they're looking for people's feedback on this. I'm sure this is going to be a problem because it's just hard to get this to work. Okay, so the final thing is that distribution is pretty hard for Gazelle extensions that are written in Go. And the evidence for this is simply if you look at things like Bazel Skylib, which distributes one of these, they made a separate module on the Bazel Central Registry called Bazel Skylib Gazelle plugin because it has Go dependencies, and they didn't want the root module to pick up Go dependencies. And so for both that one and Python, it's a little bit extra annoying to pick up those extensions. You have to depend on a separate module which downloads a second copy of the, well, sorry, it depends on the same tarball, but it has the release of the rules, and then it picks out a subdirectory, and then it installs that separately. Of course, it also means that the Go mod in your project ends up picking up these dependencies, because the only way Rules Go can compile code that has third-party Go dependencies is to create Go libraries for those dependencies, which means that they have to be listed as indirect in your Go mod so that those are even fetched. Okay, so instead of that, of course, if we write these in Starlark, then distribution is a trivially solved problem because it's just the same as distributing a rule set. The last thing I'll mention is that the API that we wrote that I'll present here for writing these extensions in Starlark is really designed for novices to use. It's a little bit simpler than the low-level API that you get from Gazelle. I joke with myself that if I had to write Gazelle extensions in Go, I would do a pretty bad job. It's a low-level language that requires some care. And if I can write them in Starlark, I'm a lot quicker, at least for me. I prefer writing them this way. I'll also point out another reason it's approachable is that since you're writing this in your repo, you can take shortcuts, right? You can hard code certain things that are just happen to be true about your repo. Certainly, you'll take that's a trade-off to decide whether it's worth it to do the general thing at the beginning or take a shortcut and hard code something, but it makes it much more simple to iterate on these and get off the ground. Okay, so I showed this demo earlier that used Aspect CLI. So if you want to use it, you just need to brew install aspect-build/aspect/aspect. You can look on our instructions for other installation for other operating systems. Of course, using a different tool than Bazel might be scary. Don't be scared. It is just a wrapper, and all the same Bazel commands will work. So if you have scripts that call Bazel, you can just drop this thing in. In fact, you can drop it in the Basilisk RC file, and it'll just turn on for everybody in the repo. And there's some other features in there I would love to talk about more. Aspect lint is pretty cool. The Aspect CLI allows you to write your own plugins, which is pretty cool. For today, what I want to show is Aspect configure. So this is what I ran earlier during that demo. I typed Bazel configure, and that caused it to generate the build files, right? And we named it configure because it's sort of like autoconf. If you come from C++, this term configure makes a lot of sense. You would type make space configure to generate the instructions for GCC in order to build some third-party software. So that's where the lineage comes from. A bunch of languages are built into there. Everything that comes from open source is, of course, available in the open source version of Aspect CLI. But the Starlark extension is not. Let's talk about how it works. So here's an example that shows what the magic was I did earlier. So I edited the package.json file. You can see here we're saying that we want to pick the sources that the thing should operate over is anything named package.json. And for each of the scripts that it finds, it's going to then generate a definition. I will show what that looks like by going into the repo where we were working. And if we look at this Starlark file that's sitting here, it's in the repo we generated. So this logic is immediately available for me to edit. And we see this for loop. It's going to loop over all the scripts in the package.json. And for each one, it will just write a JS binary target with the right entry point. Very simple. There's a lot of shortcuts in here to make it work for the demo. And in real life, you probably would start adding more logic. But this thing is only 35 lines to accomplish writing a build file generator. So that's pretty great. A couple other examples worth looking at. So for sh library, I needed this because I wanted to use rules lint to run shell check over all of our shell code. But rules lint operates over dependency graph nodes, which means that you need sh library targets for the linter to work. And of course, you might not have been required to write those because your shell code you just ran outside of Bazel. So I wanted a Gazelle extension that would they would run over all of the .bash and .sh files. Here you can see that's the list of source extensions it operates over. And then it should generate an sh library, just one per package, simplest possible thing, where the sources is the path to each of those. I put that on our monorepo, I ran aspect configure, I got sh library targets everywhere I wanted them. You can get more complicated. We had one client who wanted to see what this looks like for C++. Here we're using a couple of regex queries over the source files to find the pound include statements, which is how C++ will tell you where the .h file lives. And you can see that, well, the regex is a little bit complicated. That's, of course, how regexes are. They work okay until they don't. You go to some playground website, and on the left-hand side, you have the thing you're trying to match, and on the right-hand side, you type some regex bits, and you see when you've got it right. And that's a quick way to do it. What's the better way to do it, of course, is to parse the code, and we have that too. So treesitter is the C++ library. I mentioned that the rules Python Gazelle extension uses this already, largely for speed. That's, of course, bare metal performance being written in C++. And it has grammars for almost every language, including Starlark itself. So that's pretty great. We can just build those grammars into the Aspect CLI. Anything that's missing, let us know. We will add it. And that means that you can immediately, instead of doing regex queries, you can do what I will show you for Kotlin. Let's click on this gist. Okay, so here is kotlin.lang.star, and this one is quite a bit longer, and this shows us a couple things. One is an AST query. So here on line 35, it's some parentheses. This syntax comes from treesitter itself, and this is asking treesitter, the library, parse the source file, look for a syntax element that's an import list, and then look inside of there for something that's an import header. And then, of course, there's some extra parentheses in here, which are the captures, so that when we run this query, we can get back what the text was in the syntax element that matched. The other thing that this shows is that it needs to be able to talk to third-party dependencies too. And of course, in Kotlin, you do that by talking to a Maven rule, something like rules JVM external. And here we see a JSON query in maven.package.star. This is actually querying over the dependency list in order to find out where the dependencies come from. So with these two files, both in the Starlark interpreter where this extension runs, that means that we can look up third-party dependencies too. And so that's already working for Kotlin here. So that's great. Those are just a few examples. I do want to point out, of course, that under the covers, this is still using this awesome Gazelle system. It's just that we wrote a Gazelle extension that hosts a Starlark interpreter. It's kind of a bridge, and then it then hosts logic that you can write in Starlark. The test fixtures are the same as the ones that come from the Bazel Gazelle repo. So it's basically a little tree that has a build.in file that's like the before state. Then it has some files. This is what the tool should find in the repo. And then build.out has the after state. So if you diff build.in with build.out, you see the edits that Gazelle has made. That's how you can write tests to make sure that it's non-destructive, for example. And so for the Kotlin extension I was showing a minute ago, we first wrote that in Go because we didn't have this new system yet. Then we re-implemented it in Starlark, but we had all the same test coverage, actually. So if there are other Gazelle extensions that you've written in Go and you're considering porting them to this, that's actually a pretty great feature. The response to this has been fantastic. So I posted it on Bazel Slack, got a little screenshot here, got a wow, this is very cool. Got a mention from Constantine about that they use this in their massive front-end monorepo, the dozen plugins implemented. They were an early adopter of this thing. So it's got some good miles on it at this point. It's definitely ready to give it a try. Also, of course, I want to give a shout out to another amazing open source developer, Jason Bedard, who's on my team and is paid to work on open source. So a couple of things about what's coming up next for this. So of course, we want to be able to load Starlark from anywhere. I claimed that you can distribute these things like a rule set. That's actually not working yet. But it would look something like this. You'd be able to load from, say, rules.js to get a Starlark file. You would load some Starlark symbol. And now this is kind of an illustration of how great this could be, because you can reuse most of the logic that ships with rules.js. You can override it. And in this case, I'm saying, oh, I want to run over files that are called my special.js. So some convention in your repo is different from everybody else's. but you should still be able to, so you can customize the Gazelle extension to fit. The other thing that's coming up is that the typical developer workflow today is a little bit too manual. So you'll typically notice a build file is wrong. Maybe you try to run a program and it says a dependency is missing. And then you'll have to manually run Gazelle or Aspect configure if you've chosen to use the CLI. Of course, if you are using something that's compiled from source, then the developer may have to wait for Gazelle to build. And then they can try again. And then after Gazelle is run, presumably the build file will now be correct and the program will work. There is a tool called Auto Gazelle. We haven't hooked that into our CLI yet, but you could definitely give this a try. My sense is that it's still a little difficult to wire up for most situations. So I'm just putting a coming soon on that one for right now. Okay, so let's recap what I talked about today. So writing build files is really something developers should not be expected to do in the majority of cases. There's always 20% of deployment instructions or something that's just not present in any source files in the repo. So there's no way to expect that Bazel could have inferred those things. But for all of your regular writing source code and making it to have dependencies and the sort of fields that seem like a computer could manage them, a computer should manage them. And that is possible using Gazelle today. You can use the open source Gazelle that's on Bazel build /Bazel Gazelle. And that has some languages built in. If you'd like to try writing your extensions in Starlark instead, come over here and check out our docs.aspect.build /CLI/Starlark. And that is where you can find more examples, links to how to write the syntax I showed you, and give this a try for your own code base. So I hope you enjoyed today's episode. I know that it's a little bit different because there was a corporate pitch involved. The paid version of Aspect CLI, which has the Gazelle Starlark extension, is available today. You can use it now. You'll find that it does not have a free license. So come chat with us if you want to depend on that at scale. Otherwise, feel free to use the Gazelle open source version. The point here being, use something to generate your build files. Don't force developers to do it themselves. Happy to take any feedback of how everyone feels about the podcast having sponsored episodes like this. And of course, if your company would like to sponsor an episode and present something cool products that you've been working on, please let us know. That is very much part of the purpose of the podcast, is to present as much of what the community has to offer as possible and everything that our listeners would like to learn about. So with that, thanks for listening, and I will see you again next time.